Hello.
Hey,
Hi, everybody.
Hey, Tom, how's it going?
Yeah.
Pretty good.
Tom, are you the host here or is Nick?
It's actually me, Sage.
Yeah, so SaltStack has technically created the Zoom, and Sage is in charge of that. Because if I was in charge of it, I would forget. Details.
No worries, I'm here.
And Sage is fantastic.
I like your username, Sage. Sage the Rage.
Yeah, it's my GitHub handle too. Here we go.
So I'm excited. I just got word from the first completely independent, non-SaltStack related instance of somebody using POP from the ground up to build a piece of software, and that was and just published it. So that makes me excited that it's getting out. It's written by Daniel Robbins, the guy who made Gentoo.
Okay.
And so he's got a whole platform for auto generating and auto updating e-builds, and the whole thing's written using POP. So I'm excited.
So probably give people a couple more minutes to join up and then kick it off.
Can y'all hear my audio?
We can hear you.
Yeah. Cool. It'll be interesting to see how this goes.
Yeah, great idea. Doing the virtual meetup, you know. I think we got about 15 RCP in the Annapolis group. I'm not sure about Python or the Baltimore and Frederick groups, but I think people kind of with the Zoom link just being posted, I imagine people just kind of trickle in whenever. It's a little more informal RSVPing, so to speak.
I don't know. I want to say we had like 38 or something. Python Frederick.
Okay.
Do we have someone that's set up to quick ban folks if I don't know if you read the article. There was something a couple of weeks ago about all these different Zoom conferences going on. There was some trolls getting some links. Just trying to make sure we have somebody ready to kick folks if there's something out of hand.
That's why I'm here.
Feel free to ban me if I get out of hand too.
Oh, okay.
Yeah, if you don't like my presentation, just ban me.
All right, well, it looks like we have quite a few people on, and we are at 1 minute after. So I'm gonna go ahead and get started on the intro and housekeeping stuff and give Tom as much time as possible to speak. Well, I just like to thank everybody for attending tonight. I'm super excited about this. I hope you are too. If you're not, that's fine. I'm excited enough for everyone. My name is Nick Hughes. I'm CEO of EITR Technologies. I'm also the Cloud Working Group Captain for the SALT open source community. And I've also been doing some work creating Microsoft Azure Cloud modules for a POP project called Item. So the pluggability that Tom's going to be talking about tonight is very pertinent to that project. Due to the current stay-at-home directive in Maryland, a lot of the meetups are going virtual, and 3 of the Python meetup organizers in Central Maryland banded together to host our special guest tonight. So I'm going to go ahead and introduce those 3 guys, and then we'll go over some housekeeping items real quick, and we'll introduce Tom, and then we can get started. So Joseph Mintz, would you like to go?
Yeah, thanks, Nick. One, thanks for just reaching out about this idea. I think it's brilliant. I love now more than ever doing something virtual and keeping the community engaged. I think it's a great idea. And unfortunately, we can't all meet in person, but I'd love to collaborate with everybody again in a future event in a neutral location. But yeah, my name is Joe. I work for a company, Corporate Brokers. We're a staffing agency in Annapolis. So I know the job market's been interesting for some, with some companies doing layoffs and freezes, but we do have some clients that are hiring. So if you are in need of either talent or, for that matter, looking for a job yourself, I'd be happy to point you in the right direction. Annapolis Python Meetup has been around about a year now. We do host them in Annapolis, I'm sure you know, but various topics. This one seemed very exciting with Tom, and I just want to thank you guys for putting it all together.
Excellent. And then we have Matt Lehman.
Yeah, I run the Python Frederick meetup, and I actually had invited Nick to come speak about SALT, and we got the directive like the day of that the college we were going to meet at was closed because of COVID-19. So Nick, thank you for doing the legwork of getting Tom to speak for all the groups. I think that's awesome. I'm really excited that we have this opportunity. Yeah, so thanks.
Yeah, awesome. Yeah, I was all prepared and ready to come out there, and they shut down the school literally right as I was about to get in the car and go. So that was an interesting experience. And then Brian Burgess, do we have you on?
Hey, man.
Hey, you want to go ahead and introduce yourself?
Yeah, so again, Nick, thanks for pulling this all together. My name is Brian. I'm principal of a company in Columbia called iSystematics. We meet regularly. We're always looking for volunteers and speakers. So if you want to find out more, you can check out our Slack channel. I think we've done probably 3 or 4 topics on SALT. So we've covered just general SALT, execution modules, and beacon systems. So I'm really excited to see the pop stuff. I'm kind of new to it. So super excited. Thanks again.
Awesome. So as far as housekeeping, please stay on mute during Tom's presentation. If you have any questions, go ahead and ask them in chat, and we'll see if we can interject them into the presentation, or we'll take some Q&A if we have some time at the end. And so let's go ahead and get started. So we have with us tonight Thomas Hatch. He is the inventor of SALT, one of the largest open source Python communities out there on GitHub right now. He is CTO and co-founder of SaltStack, and he is also the star and co-host of the Hacks podcast, which if you haven't checked out is very good. You definitely should. So go ahead and take it away, Tom.
Hey, thanks, Nick. You give me better intros than I give myself. So I'm going to actually start by sharing. Can everybody see my screen here? It's nice when you can begin a presentation about something that you wrote with somebody else's words. So Daniel Robbins recently put some of this up online as he's working through migrating a bunch of tools for the Fun2 Linux distribution over to use POP. And as he puts it, let's see, Fun2 MetaTools uses Thomas Hatch's POP plugin-oriented programming framework as its foundational paradigm for code organization. POP is a next-generation framework that encourages code maintainability and extensibility and successfully solves code bloat problems inherent in application of object-oriented programming paradigms at scale, many of which the current Portage code base suffers from. Portage is not unique in this regard. It's been around for a while and has a ton of functionality bolted on. And this has resulted in a large monolithic code base with a lot of functionality. And yet as a code base, it is hard to improve and adapt. This is, and I love that and I'm excited to have that intro. I mean, he just sent that to me 10 minutes ago. And I feel like that is an excellent way to dive into this, primarily because, man, that's where it is. I forgot for a second how to move to presentation mode. It's as if I don't do this 5 times a day. Maybe not that often, but pretty regularly. But that little blurb from Daniel describes really succinctly what I'm trying to do with POP. So, plugin oriented programming. Let me begin with a quote from Linus Torvalds, not about POP, of course, but just a general good old Linus Torvalds quote. Back in November, in an interview, he was asked if he gets to write code anymore, and he said, "My job really is, at the end of the day, to say no. Somebody has to say no to this patch or that pull request, and because developers know that if they do something that I'll say no to, they do a better job of writing the code." So Linus Torvalds, he then later goes on to say that he's fine with the fact that his life is now that of a gatekeeper. But the point I'm trying to make in presenting this at the introduction here is that we have taken who is one of the most brilliant minds in computing and reduced him to somebody whose job it is to just angrily say no to everybody. And that makes me feel as though something's kind of wrong with how we write software. If that is the destiny of our best engineers. POP is built to allow code bases to be externally augmented and merged. Now, this idea is that if you write a piece of software using POP, somebody else can extend your software and they don't have to give you their code to review. They can extend your software, and then their own extension to your software can develop merit on its own, so that you don't, instead of having a community argument about should this piece of software be merged, you can very easily say, oh, hey, you know, this other piece is being used a lot. Maybe we'll make that part of our default install. It ends up treating a piece of software more like you get the benefits of a programming language that anybody can write something in Python, but that's for every single application that you get. That also means that you can augment your code differently. And so this takes a completely different approach to just fundamental software engineering. And plugin-oriented programming has shifted to be virtually all of the new software that we're producing at SaltStack is running using plugin-oriented programming. We've got quite a few projects out. And again, like I was just showing you, we're beginning to see independent projects happen with POP, even though it was only announced publicly last November. Finally, another quote from Daniel Robbins, because this was already in my slide presentation, as he said, "POP is becoming a virus because it's taking over my code and killing off weak patterns. I have a lot of code that sort of reached its potential with just modules and classes and was just sitting there waiting for something like this." So who am I? Nick already gave me a fantastic introduction. I am a loudmouth who thinks that it's okay for me to have created a programming paradigm. It's implemented in Python, but right, I am a sufficiently egotistical maniac that I've written a programming paradigm. So given the fact that I've already written Salt and a few other put a lot of major projects out there, I thought perhaps I might have the clout to sell a programming paradigm to the world. So it's worth a shot. But one of the things that I want to emphasize is that I've spent a considerable amount of my career working with some of the largest and most complex code bases and infrastructures on the planet. My expertise in complex systems is pretty solid. So there are definitely a few corner cases around scale from a POP perspective and scaling code, but many of the core principles are built to allow us to create much larger and more flexible code bases without those problems that we run into with large code bases. And so I'm gonna talk through how this works and where some of this comes from. So, programming paradigms. I want to go over a brief history of programming paradigms to frame what most of them were actually made to do. When we step back and we look at programming paradigms, many of them came from all the way back into the origins of computing. When we first developed computers, the job of a computer was to do math, right? Computers obviously can do math faster than us. And shortly after that, we started to develop this concept called an operating system. We go back into the 1960s, and operating systems start to be developed with the Multics operating system in earnest, and then the Unix operating system that actually took over and turned into what is still today the dominant operating system construct in the world today. The Unix operating system developed the Unix philosophy. The Unix philosophy is something I'll talk about a little bit more, but one of the things that is incredible about the Unix philosophy is that there's really two ways to build an operating system. Two ways that have proven themselves successful. And one is the Unix way, and the other is the Windows way. The Unix way has proven successful because it can be done with very little resources by extremely distributed teams of people who are able to contribute small and isolated pieces of code that extend the functionality of an operating system, which is why we can have a Linux operating system today, which is so much more extensible and powerful than large proprietary operating systems for specific tasks, that has been developed with a tiny fraction of the investment capital that needed to go into the development of large proprietary operating systems. So at this point, we're still in the 70s though. We've got some operating systems and code is logical and procedural. So programming paradigms up to this point have been built almost entirely to either express mathematics or to just give you access to the hardware. That's in large part what C is a procedural paradigm, but a language that gives you access to the hardware. These paradigms are simple, they're elegant, they're really beautiful programming paradigms. At this point, object-oriented programming has been developed. Object-oriented programming stemmed from the original idea of saying that I have structures and I want to be able to interact with those structures. Object-oriented programming is a very natural way to build a programming language. If any of you have ever built a programming language, just for fun, I've certainly not built a real one, but you know, when you build one for fun, it doesn't take very long until you want object-oriented constructs, because it makes it very easy to say, now I have a type. It's a lot easier to create an integer or a string if you can first create a class. And so these constructs go back a long time into the days of Smalltalk. But object-oriented programming only became really popular with the rise of Windows. Because with the rise of Windows and the rise of the desktop and the desktop GUI, we discovered that object-oriented programming makes a lot of sense for building desktop GUI applications. Because you've got that construct of having a bag that can contain a bag that can contain a bag of code and functions. And it's close from a paradigm perspective to how you end up visualizing the software. Well, computing as we know it has evolved into the world of today, where we have SaaS applications, huge amounts of software and UIs are piped through this platform that we use called a web browser. And all of the different paradigms throughout the history of computing are very critical to how this whole system now works, because we need to be able to make we need to be able to do math and heavy level operations and database operations. We have to manage operating systems. The Unix philosophy is alive and well as we try and express it through Kubernetes, where we try and have many microservices. And then we still have object-oriented programming and UIs and functional program. You know, it's all just this mess of paradigms and concepts that we've used to create the modern SaaS world. But also, we now have code bases and infrastructures that are exponentially larger than anything that we've seen in the past. So that leads us to the problems of today and some of the limitations of object-oriented programming, but also limitations that we run into with many of the paradigms and constructs that we have. And again, I want to put a lot of emphasis on that I'm not an OOP hater. Object-oriented programming and so many of these things that we have given us so much. And plugin-oriented programming is built on top of object and uses object-oriented programming constructs. But my argument here for a new paradigm is that we need a top-level approach. We need a paradigm approach that is able to say, how do we build software that appeals to how people think, instead of building software and paradigms around the abstraction of the machine? So we need a top-down approach instead of a bottom-up approach. How do we deal with scale issues of monolithic pieces of software? Salt is over 1 million lines of code, and testing it has become quite onerous. Testing almost any large platform becomes onerous very quickly. And so does allowing lots of people to work in that code. Salt is good at having lots of people work in its code because it's pluggable. But it still has constraints as to how it intertwines, just again, because of the size of its code base. Also, this is a theme that you're going to see come up, and that's the dark side of pull requests. I have spent a considerable amount of my time reviewing other people's code. And I've spent a considerable amount of my time not only being grateful for contributions, but I have to be honest, also regretting contributions that I merged. Because then they give me the code and it's now my responsibility. And the buck has to stop somewhere, which becomes a problem in long-term and large-scale code maintenance. And so pull requests, I have to argue at this point, I think they have a potential dark side. And when you get to larger projects, there's more pull requests that can possibly be managed, especially managed by people who have a deep enough understanding of the code base to be able to deal with the influx of that code. One of the last things on here is the Mythical Man Month. Normally I ask people to raise hands. It's a little harder to present to a room when I can't see everybody's faces. But typically I ask, who's read The Mythical Man Month, which is a fantastic book written back in the 70s. It was written to try and train managers to understand that managing engineers was different from managing an assembly line. A problem which occasionally rears its head even today. And one of the points in the Mythical Man Month is that if you want to double production with an assembly line and you've got 3 people on the assembly line, you make another assembly line and put 3 people on that new assembly line, and you have therefore doubled output. But as we all know, that doesn't work with software engineering. If you just hire 3 more software engineers, it doesn't double output. But POP is designed to try and better scale the people so that we can have greater output and greater maintainability of code. And finally, I want to address freedom. Open source software was in very large part created to promote the freedom of the developer. But what it's turned into, and I've seen this happen with so many open source project leaders, is that open source software turns into a cage for those developers. they become tied to their project. They become really bound by it, and I've watched it play out so many times where the stress just destroys these brilliant software engineers. I don't want open source software to be a cage for the people who write it. I want open source software to be a means for software developers to continue to express their ideas and get them out there without having to maintain giant communities and giant pull request lists. Instead, being able to focus on where they're good and get that work done and do it well. And so with those problems, this is why I want to introduce plugin-oriented programming. Plugin-oriented programming follows the Unix philosophy, but it changes a few things. Honestly, just one thing in a very menial way, to be able to make it scale to modern projects and modern problems, and to deliver freedom to software engineers, and not just open source software engineers, but hopefully to also deliver freedom to software engineers working in organizations and companies and corporate environments, so that they are more scalable and more flexible. They can move to new projects more easily, and that engineers are less likely to become pigeonholed by their own code. So I am honestly trying to create more freedom for us. So if we were to revive the Unix philosophy, the first two things don't actually change. You write a program that does one thing and does it well. You write programs that work together so that they can interoperate with each other. And then the third line, the third rule of the Unix philosophy was write all code so that it uses text for input and output, because that's the universal communication stream. This is arguably no longer applicable. We can't just rely on text streams and a pipe on a command line like we could back in the early days of the Unix philosophy. So my argument with POP is write programs that expose consistent interfaces that can be merged together. And this is a huge concept in POP called app merging. Any two applications that are written using POP can be merged into a single application without any difficult work. They just work together regardless of interfaces and APIs. And this is where this wonderful concept called app merging comes in and allows us, I would argue, to revive the Unix philosophy. So let me talk briefly about where plugin-oriented programming came from. So I wrote a plugin system inside of Salt. And a few years into Salt, a question went out to many members of the community and said, what do you think the most brilliant part of Salt is? And got a bunch of answers back, and then one person answered, it's the plugin system. It's the Salt loader. And I hadn't really taken it that seriously yet. I just thought, well, I need a plugin system to be able to solve these problems, so I'll make a plugin system. So this one guy says, I think it's the Salt loader. And all of a sudden, everybody else started rescinding their answers and saying, oh, now that you mentioned it, it is. It's the Salt loader. It's this whole plugin thing. And it made me step back and think, if this is such a good idea, maybe I should try and make it stand alone. And so I made a version of the Salt loader called Pack. And I didn't release it because I never finished it. I never got it working the way I wanted it to. But I learned a lot. And then I thought, well, I wonder if I could write this in another language. And so I tried to write it in C and C++. I started writing it in OCaml and Go, started writing it, and then I implemented it in Julia. And if you haven't played around Julia, it's such a cool language. I love Julia. I'm a huge fan. by the time I wrote it I implemented it in Julia, it really opened my eyes to a lot of different ways of thinking about building pluggable software. And so then I came back and I rewrote it yet again in Python, but now from a completely fresh perspective. And took that system and we used it for some of our proprietary software inside of SaltStack. And I learned a lot more at that point, and then forked it yet again into POP. And so POP is literally I don't even remember how many iterations on the idea. So I guess my argument here is I didn't just come up with this overnight. I've literally been working on this thing for the past 8 years of my life. And even though I've been working on it for a long time, it is tight and elegant. And I've tried very hard to make it so it's not sprawling. I've thrown so many things away and built on many other things until I felt that it solved a sufficient set of the problem set I was trying to solve, that it was worth actually sharing with the world. POP is, of course, implemented in Python and released under the Apache license. So you're more than welcome to use it. So if we're going to say this, call a programming paradigm plug-in oriented programming, we need to ask, well, what does it mean for something to be pluggable? And so there's some rules of plugins, and following a few simple rules of plugins means that every aspect of your software becomes pluggable. And so if we follow the rules of plugins and we learn the basic concepts of plugins, then we understand how to make software, again, where everything is pluggable. But also when everything's pluggable, then everything is also mergeable. Making a plugin paradigm doesn't just mean that we make software that's made out of lots of plugins, which was my thinking about 2.5 years ago. It is that the entire pieces of software that you have, again, can merge together seamlessly, so that your actual piece of software is pluggable. So we do this with a few simple constructs. And so this is the point where I'm actually going to ask you to remember some things instead of just some pie in the sky philosophical bullcrap. Plugin-oriented programming begins with a building block called a subsystem, a plugin subsystem. And I'll refer to them just as subs moving forward. But a plugin subsystem allows you to say that I'm going to define a pattern that plugins will follow, and kind of just a container for plugins. A plugin subsystem can be compared as far as importance to the paradigm as a class is to object-oriented. It's the fundamental building block of plugin-oriented programming. And so these subsystems contain plugins and the subsystems contain data. And so that's one of the fundamental, very important concepts inside of plugin-oriented program or object-oriented programming, is that we allow data and functions to exist inside of the same namespace. And so we're certainly following that model here. But again, it's different in that it's a container for many plugins. Okay. So I meant to take that last slide out. Sorry about that. So if we come back and we look at the rules of pluggability, we have subsystems that contain plugins. Plugins express the pattern defined in the subsystem. If plugins don't conform to that pattern, you make a new subsystem or a new sub. Plugins should always be small. If the plugin cannot be explained to another engineer in a few hours maximum, it is not pluggable. Subsystems should be small. If the pattern and the way to use a subsystem can't be explained and transferred to another engineer in a few hours, it's not pluggable. And so one of the concepts of scalability inside of this paradigm is that everything can be broken down into elegantly small components but merged together into a large whole. That means that the components can be more easily maintained by individuals. All of these subsystems get brought together on a hub. The hub is the root of hierarchical namespace. One of the challenges that we run into with object-oriented programming is cobbling together lots of silos. When we write object-oriented programming, we create silos that contain data. And I can't tell you how many times I and many other software engineers I've talked to, their code doesn't need to get very big until they get to the point where they say, I'm over here in this class, and I really wish that I had access to some data in an object over here. Well, how do you solve that? You do one of a couple of things. Many of us are at this point tempted by a great evil, and that is that we just start using globals. And of course, we shouldn't do that. And so we say, okay, I won't use globals. I won't succumb to the temptation of making it easy. And so then we just go back up the call stack, right, until we get to that shared place. And then we send the data down the call stack, which in and of itself is cumbersome, requires refactoring, and doesn't scale. The hub creates a hierarchical namespace that all of your code and data exist on. And that data is world readable, but namespaced. Because the problem with globals isn't just that they're evil. The problem with globals is that if you've got multiple applications using the same data, then you have to deal with who has access to change and manage that data. And where do the globals come from? And are their origins relative to the code that created them? A hierarchical system solves the problem of globals, which means that we can still make this information readable to the rest of the application while still exposing the information in a consistent way using API models so that you can say, this is data that I'm okay with you publicly reading. This is data that can be changed by everything deeper inside of my namespace. This is data that can only be changed in this part of the namespace, but I want to expose to the world. And this is data that I don't want to expose or is private to these components. So that we're able to create a system that doesn't need these nasty call stacks and silos, but everything is accessible on a hierarchy. And so then that namespace itself gets some rules. So anything that's deep on the namespace cannot be modified by anything that isn't in its namespace location. All right. Now I've mentioned app merging a few times, and don't worry, I know I've talked too long. I have violated one of the rules of presentation giving by talking too long and not doing a demo. So I'm almost there. Don't worry.
Hey Tom, there's a question in the chat.
Oh, is there? I can't actually see the chat.
How would you compare it to the decorator pattern of OOP or OOP? I assume that means pop.
Oh, how would I compare it to the decorator pattern in object-oriented programming? There's a number of places inside of plugin-oriented programming that extend the decorator pattern. One of the things that I don't like about the decorator pattern, I shouldn't say don't like, one of the limitations I feel that exist inside of the decorator pattern is that you are still explicitly decorating specific objects or functions. And so that decorator pattern still means that you've got to be able to import on a file level and then decorate and then have a separate controlling instance. So my argument for a hierarchical system is that you don't have to do any of the linking as a developer. The other thing is from a decorator pattern is that it restricts the malleability of the software. If you have to decorate objects, then it makes it more difficult for your software to merge with other pieces of software. And so when you merge with another piece of software, yes, you can expose an interface through those decorators, but then the other pieces of software have to inherit components of your own internal interface for those shared constructs. And when that happens, you get multiple code bases that have incompatibilities with each other. Whereas if we use a unified hierarchy, then we can merge multiple applications onto that hierarchy, and those constructs become consistent across multiple applications. Did that answer your question? Or did I just confuse things? It's so hard when you can't see a person's face, right? I'm used to somebody going, or what? And then I can change things around. Thank you, Mike. And I'll remember to keep the chat window open. All right. Given the amount of time, I'm actually going to skip a few of those concepts and try and dive right into a demo. So there's, when you install POP, and you can just pip install POP, it comes with a little tool called POP Seed. POP Seed makes it really easy to start a new POP code base. It gives you all of the Python boilerplate that you could possibly need to be able to run that application, okay? And so now I'm going to stop share and transition to a terminal. Okay, can somebody tell me if that's big enough? Everybody's got decent monitors? What?
Looks good to me.
All right, thank you. So I'm gonna make a new project. We'll call it Poppy because I'm not very creative today. So there we go, I've got an empty directory. So POP Seed exists to make it really easy to be able to make a nice new consistent project. It makes all of the files for you. It actually adds a pre-commit, which you're more than welcome to delete, of course, if you don't want to have a pre-commit check inside of your system for to apply black on your code. That's in there because that's the default model that we're using moving forward. This isn't a talk on black, so we can have lots of arguments about that some other time. Certainly something worthy of an argument. For those of you who are unfamiliar with black, it's totally cool. It's an automatic Python code formatter that guarantees that the code before and after the format still adheres to the same abstract syntax tree as presented by Python, meaning that it guarantees consistent functionality of code post formatting. All right. So anyway, more importantly, it creates a nice setup.py for you that you don't need to edit beyond putting a description and like your name on the bottom of it. I'm playing around with also making it generate the necessary options to make the project fully functional inside of a PyProject.toml so that it would also work with tools like Poetry. It creates a run.py, which is all you need to initialize plugin-oriented programming. It creates the hub, the root of our namespace, and then subsequently adds the first plugin subsystem, saying that the dynamic name of this plugin subsystem is Poppy, and then calls the CLI function. The hub gets created. When we create a hub, it automatically gets its first plugin subsystem so that we can be turtles all the way down. so that any manipulation that you have about your own hub or any working with your own hub to extend it is all done inside of its own namespace. And so how this works is we have the hub, and then we have a subsystem, in this case, POP, a plugin, in which this case is sub, because it's a plugin that's used to manage subs, and then a function. And then this function is just saying we're going to add on to the sub a new subsystem. We're going to add a new sub called Poppy. It uses the dynamic name system, which means that it goes out and it figures out where this new plugin subsystem is, and then adds it to the hub. And so now we've got a new namespace extending our hub. There's a plugin in there called init and a function called CLI. And so if I execute my run program here, it works. Which of course would be deeply embarrassing if it didn't. I'm sure we'll get to the point where there's a demonstration I give that something doesn't work. So actually, what we're looking at here then is we've got a Python package called Poppy, which is really the Python vehicle of delivering pop code. Inside of Poppy, there's a conf.py and a scripts.py and a version.py. This conf.py allows us to define all of the subsystems which are being abstracted. Okay? And so we're able to say that this Python package provides the dynamic name subsystem Poppy, and you're going to find that name Poppy if from here you import Poppy. You'll notice there's a few other things in here. I'll cover those in a minute. And so that means that the Poppy subsystem is now defined in this directory called Poppy. We can have multiple plugin subsystems inside of the Poppy package, and we just add them to that Dyn dictionary, and then they become app mergeable. Again, more on that in a moment. The init.py is your subsystem's initializer. Your subsystem, every time you make a subsystem, the init.py is loaded first, and and for any plugin in the system, if it has a dunder init function, then that function is called when that plugin gets loaded. So it makes it easy to be able to set up any data structures that you might need. The next thing that we do is we load up all of the configuration for this CLI application. If we're merging together multiple applications and we want to scale, we have to be able to dynamically merge the configuration of multiple applications. Now, for many people who write software, they've never written a config loading system. But so this function gets called, we load the config, which at this point is still optional, don't get me wrong. We haven't actually added any config. And then we print out Poppy. And so that's your code path. This is basically where this application begins, okay? Now, when you write, the reason why many people have not written configuration loading systems for software is because a lot of people come into a piece of software as a developer once it's already grown in size a lot, or when they write a little script, they go, yeah, I'm going to use argparser and I'm done, right? I don't need this big fancy stuff. One of this concept of app merging means that you're able to make lots of little applications that merge together. That means that the way in which they merge together matters with respect to how they are configured and loaded, which also means that we need to be able to facilitate multiple application merges inside of the configuration layer dynamically in such a way that it is not cumbersome to the end user. so that you can say, I'm going to write this one application and it's going to merge these 37 other applications. It's going to inherit the configuration of these 37 other applications and then expose a specific CLI for my application, which is a terribly complicated thing. And then we also need to, from a back-end perspective, for the user of POP, it's easy. We also then need to be able to take configuration from multiple sources. So when you're loading up configuration, you've got to be able to take configuration from config files, you've got to be able to take configuration from the command line, and you've got to be able to take configuration from environment variables. And then you've got to have configurations that come from a default. So you got 4 config sources and they have to be loaded in the right order. And if you use Python, you would generally use argparser, where you define your defaults with your CLI, and which means that after you load your CLI, you don't know what your defaults were, which means that you don't know what to overwrite and not to overwrite from a config file, and you don't know what parts of the config file to overwrite from OS environment variables. Pop does all that work for you, so that this now is a functional config, assuming I don't have a syntax error. Nice. And there it is. Again, it's built with the intention to try and make your life as easy as possible at the beginning, while still being able to scale to manage multi-million line of code projects, which is in and of itself an incredibly, again, it's a very complicated problem set. Okay, so every now and then somebody is like, hey, Tom, that's overkill, you don't need that. I'm like, yeah, sure, you don't need that until you've merged 4 applications together and they collectively are 50,000 lines of code. And then you go, oh, I'm glad that we thought of that. Okay. So those are some of the basics. You can see that where we've got code, where we're able to add plugins. And so then the next thing that I want to cover really quickly is, let's say that I wanted to call another plugin. Let's call it foo, because I'm not very creative today. And so now I say hub.poppy.foo.run. Okay. Now, I'm going to transition. Let's do corn. For those of you who are aware of Salt, Salt has a facility inside of itself called Grains. Grains scan a system and come back and say, these are all of the properties of a system, and then it puts it into data structure. So I've got another system over here called Corn, because Grains was taken on PyPy, that's written in POP. And so Corn is a very small code base And this is where I'll show off what we call vertical app merging. What Corn does, here we go. Here's my CLI function. So this is what gets read from the CLI. I load up my config. I take my config values from Corn and I merge in another piece of software called rend, which is used to render data files. And I then tell the config loading that Corn is the authoritative source for how to construct your CLI. I then execute run standalone. This starts an async IO loop with the collect function right here that we see we derive from hub.corn.init.collect because I am in the Corn subsystem in the init plugin, and there is my function. I call this run sub function inside hub.corn.init.run sub. And then this takes a subsystem, which in this case is hub.corn. It iterates over that subsystem because everything inside of POP is iterable and introspective. Fix that real quick. We updated that to make sense. And then for each function in the module, we execute the function. If the function is a normal old function, then we're done. If it's a coroutine, then we append it to coroutines and we empty them out. And yes, I could have used async io.gather, whatever. I probably wrote this before I realized that that was a function. Okay. And so that now means that I have a pattern. Any file or any plugin that I add to this directory will be automatically processed by Corn. And so now, if I execute it, this is what I get for having a development version of my software installed. Like I said, I knew that something would break. Okay. And so therefore it's gone and it's loaded all of the code that was inside of the Corn sub, executed it, and it now has revealed to everyone that yes, I am certainly running Arch Linux. But now you're saying, but Tom, there was no code inside of that subsystem. And this is where app merging comes in. I only want that application to maintain the logic for parsing out and reading all of those plugins. I only want this application to contain the logic that says this works by gathering this data. I don't want this application to do anything else. I want it to be small. If it is small, it is maintainable. If it is maintainable, I can explain the entire code base to another developer in a few hours to a few days, and then I am free from that code, and it doesn't follow me around because I could give it to somebody else, and that's elegant. And so then, if I go to another code base, in this case called Item Linux, now I have providers for detection of components on Linux in a different code base so that all my information about Linux can be developed by Linux people And similarly, I can then make one called Red Hat. So all the Red Hat specific detection components are just there for Red Hat and developed by people who specialize in Red Hat. And I can have one for Windows that is developed and maintained by people who specialize in Windows. Okay, and so then I come in here and this is a POP project. It's going to have a conf.py. There it is. It is saying I also contribute to the Korn plugin subsystem. And there it is, just like that, my Dynamics name, just like it says in the dynamic name definition. And there it is. Here is all of my code for detecting information on Linux. Nicely broken out into lots of nice little plugins. And so there's a plugin that does the specific things that I needed to do. And finally, if I come back and look at Korn, and again, for those of you who are SALT people, this totally solves that whole giant core.py problem in grains that is like, oh my gosh, because now everything gets to be spread out and it can be loaded in a deterministic order and we can do concurrent detection and it's significantly faster, yada, 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 yada. So where is I looking? That's where I'm looking, okay. And so then at the end of, what was it? Oh yeah, it runs CLI. At the end of CLI, we say, okay, I've run standalone, and then there just happens to be, here it is. On the hub, there just happens to be this new data structure called Korn. And I actually made it up here, see? So when I initialized Korn, I made a data structure. That data structure has now been communicated because of its location on the hub. It's been communicated that everybody who is below Korn on this hub has write access to this data structure because it exists under Korn. It's all caps, so we know that it's a variable. If it was lowercase, then it would be a function or another sub or a plugin. If it was camel case, we would know that it is a class. And so now all those plugins have to do is follow a simple pattern. So anybody can really, really easily extend Korn, and then they don't have to give me a pull request to do it. They can just make a new Python project and put it on PyPy, and if they install it, it gets dynamically added to Korn. Okay? And then Korn itself doesn't have to care one whit about all the code that is actually doing the ingestion. So how does something like Korn know the right set of plugins? If you have Windows plugins versus Linux plugins, how does Korn know to run the Linux plugins on a Linux box? So there's a couple of ways in which this can be solved using POP. One way to do it is through the contract system. So it's very easy for Korn to create what we call a contract. A contract then is able to wrap plugins. And so it would be very easy for Korn to have a contract that says only run a function only run a function derived from these plugins if we're on Windows, only run a function derived from these plugins if we're on Linux. And then that wrapper gets automatically applied to all of those functions so that it can be easily wrapped in such a way that is completely transparent to the developer who is extending the application. That's one way. Another way in which it can be done is to only install Windows support on Windows and only install Linux support on Linux. So a couple of ways in which it can be done. Generally speaking, I would say you should do it with a contract, make it nice and elegant. I love when somebody accepts an answer. Thank you. Every now and then it doesn't work, right? Okay, so I've tried to cover as much as I can given the time which has been allotted. I'm under the impression I'm out of time. Nick, am I out of time?
Well,
He fell asleep.
I guess that really depends on you.
So I mean, I could talk all night. I mean, I say I could talk all night. I've got a meeting I've actually got to be in a half hour. This is one of the challenges of these remote ones. It's not like I flew somewhere and I just get to tell everybody, no, I'm going to be eating dinner with everybody all night long, which is usually what we do, which is lots of fun. So we're certainly missing out on that part of of going out and hanging out with everybody and going to a pub and yeah.
So
I've got another half hour. So does anybody have any questions, comments, arguments, or rebuttals? As I am presenting an entire programming paradigm, there's lots of room for arguments.
Tom, so going back to the philosophical part of pop and why pop and the origins, I totally appreciate and understand why you would want to build a paradigm that would allow you to step away from the sort of your own project becoming your own cage. That makes complete sense. The worry that I have is, I don't want to use a word like abdicate, that's the wrong word, but I feel that like, how can I trust a piece of software that takes that approach to development? Like today, I know exactly where SaltStack comes from. I can trace its progeny all the way back to this GitHub repo. But now if we're moving to this architecture where there's the core, which is totally stable and easily handoffable, but consists of an ecosystem of effectively code written by strangers, where do we start selling, say, a program or a product that has that kind of approach?
That's actually a fantastic question. So let me answer it by showing you another piece of software inside of the ecosystem. I'll go to Poppy to do this. So these extensions only become active when they're installed. And so the goal of this is actually to increase the amount of trust that you have. Because one of the challenges that we have from an open source perspective is that, yeah, SaltStack is saying, I'm going to do everything I can to maintain all these contributions. But that has inherent scaling issues, right? Because then that means that there's a limit to the size of SaltStack's shoulders. And so we're addressing this problem much in the same way that it's addressed with Red Hat and Ubuntu. So Ubuntu comes and says, we have a core set of packages that we promise we have done a really good job on. And then we have universe and multiverse, okay? When SaltStack distributes a piece of software using POP, we will distribute it with what we say has been blessed, right? We've looked at these, we agree that these are good. And some of those might be a community project, but we would only distribute a third party if we've said, you know what, these guys are on the ball and we have vetted them. And we trust that they're not going to make a mess of things. The same way that Red Hat says, I'm going to install Apache because we trust Apache. I'm going to install Nginx because we trust Nginx. I'm going to install SSH because we trust the SSH team, despite the fact that they're funded by Putin's cronies. And that's a joke, by the way. If anybody's familiar with that funding. But you get what I mean?
Yeah, that makes sense. When you phrase it that way, like drawing parallels to a software project being similar to the way an operating system is going to distribute and make available various packages. That helps a lot, actually. Thanks.
So the other thing that I'll mention is that one of the challenges that we've got with distributing Python software in general is just, well, one of the challenges with Python is distributing Python software, right? And one of the policies inside of SALT for a long time was to say, we've got a minimal set of dependencies because I just don't want to have to maintain this huge package tool chain. And we have to maintain that now. So coming right back into it, there's a project called Pop Build. Pop Build, and again, I've got a development version of this, so when this blows up, I apologize. Come on. Pop Build builds either a single binary of your project so that it can be distributed just as easily as a Go project.
I would love to see this be a real thing that everybody knows and acknowledges. I can't wait for this reality. I feel like we've all collectively punted. Like when containers became available, we were all so excited because it contained the damage. Something like this would be amazing.
So here it is. It's running a little slow because I'm running Zoom, right? And Zoom loves to just take all your cores and all your RAM and gobble it up. And I totally need to make it so that line is not a red error because it's not an error. What Pop Build does is it uses PyInstaller, but PyInstaller has some issues, right? And most of those issues arguably around usability and the corner cases in which PyInstaller falls down and breaks. It wraps PyInstaller and fixes all of the reasons why PyInstaller would break. And automatically forces PyInstaller to basically not make a binary that doesn't work. And it allows, so now now granted it makes some big O binaries, but it is a single binary.
I mean, compared to a lot of Go binaries I've seen, that's really not that bad.
Right. I mean, and actually when we build all of SALT using Pop Build, it's about 45 megs, which for a project the size of SALT and with the dependencies of SALT, that's not that bad.
Actually,
But yeah, so now I can do dist poppy and there we go. And it's all in there and Python's in there and everything is in there, okay? And unlike a Go binary, it actually doesn't load every aspect of what's in that binary into RAM. Okay. So I'm going to answer Valrun's question, and then I will answer your question, Matt, because I totally deal with Dunderfile. I have to, because they're all plugins that are dynamically loaded through relative location on a file system. Okay. So Valrun's question is, this is a very basic question, but an excellent question nonetheless. Basically what it boils down to is, you said that POP extends OOP. Do I need to understand OOP before doing anything with POP? You do not need to understand object-oriented programming to use POP. All of the constructs and capabilities of object-oriented programming are available, of course, because it's built on top of Python. But what I generally argue is really elegant POP code makes minimal use of classes. If you do things right from a POP perspective, the need for classes gets reduced down to almost only if you need to make a type, right? If you really need to make something that behaves like an integer, right? That's what OOP becomes the thing that you use it for. instead of traditionally what you would use OOP for. So that means that, no, you can learn POP without really knowing anything about OOP. Okay, and Matt, your question about dunder file. In that executable, how do you deal with dunder file? You're welcome, Valrin. Thank you. So what PyInstaller does is it looks at a lead file. In this case, it's that run.py that was generated by PopSeed. PyInstaller looks at the lead file and then traces all of its imports. And then it brings in those imports and then bundles them into a binary. But the imports that PyInstaller creates in that binary train, so to speak, still get laid out from the binary inside of a zipped Python environment. And so the way that we deal with dunder file is that we actually bypass large parts of PyInstaller's single binary bundling, and we overload its utilization of a bundled zipped environment, Python environment. And so when this is executing, any file that is in there is accessible via that environment. And so that's really how we get past the dunder file problem inside of PyInstaller. It makes slightly larger binaries, don't get me wrong. But it means that dunder file is frankly fully operational. We will also pack any data files automatically. So if you put a .json file in there, that's going to be in that binary and it's going to be accessible relative to the dunder file reference that you get out of that file dynamically when it's loaded. But it gives us slightly larger binaries. Now, one of the other problems I'll cover really quickly as well is that since it's a zip environment, it means that every time you execute the binary, that zip environment gets unpacked. That's a native issue with PyInstaller, and really a native issue with almost any freezing technology that allows any sort of resolution to dunder file. This is solved with pop build by using the one-dir directive. So I misspelled it. So the one-dir directive says, instead of creating a single and that's very similar to how Shiv works, and I'm familiar with Shiv. I'm not deeply familiar with Shiv. I've heard of Shiv. So yeah, that's basically what we're doing is we're still extracting it to a local directory and then it gets auto cleaned up. But if you don't want that mode, this is what one-dir is for, which can make it really easy. So when we're distributing packages with pop build, and so clearly, in a nutshell, I'd love to do a whole nother presentation to you guys on pop build because it is one of my favorite things in the world. And it just makes so many Python problems go away because I want that. I want the convenience of Go, but not to have to write software in freaking Go, right? Because Python's better. It's way better. And it's actually really hard to make pluggable software inside of a language that only abstracts completely static and static binaries. So now under dist, I've got this directory called run, which is actually all the crap that goes into the binary. And if I do dist run, then there we are, okay? But now everything's already unpacked in a directory. And so if you want to make a single file for somebody to download, you can make a single file. if you want to make a directory that is faster to execute and executes, I would argue, more cleanly with respect to the target operating system, which is an OS guy I care about, then you would do the wonder and then you would package it all up. And so if you wanted to do that, then you would do this right there. And so now what I'm doing is I'm saying, hey, pop build, I also want you to make me an Arch Linux package of a wonder distribution. And so now it's going to spit that out. Okay. All right. So sorry, that was an extremely lengthy question that was almost an entirely additional presentation. Pop build is not restricted to pop projects. It should, all its testing is based on pop projects, and I'm using it for quite a few pop projects, but it should work for any Python project. And I'd love to see it as a tool for building for any Python project. Yeah, but again, I'd love to give you guys a more robust presentation on pop build and how all its pieces work. Yeah. So yeah, any other questions, comments, arguments, or rebuttals?
Can I ask another one? I gave it 5 to let someone jump in. More
yeah. Go ahead and ask, and then I'll ask Mekas or Mikas,
work.
or however you say that.
More an observation. You're familiar with build packs, right?
Yeah.
So like pop build just seems like a much more elegant solution to the typical Python build pack.
Yeah.
Okay, that was it. Just an observation.
Thank you.
So I mean, I don't know if this gets traction, I can see in some time this being how the Python build pack works. That'd be pretty cool.
Yeah, and actually remind me, it's been a while since I've looked at build pack. What's its artifact?
That's a good question. It depends on who you ask. I mean, I'm living in a world where like everyone's trying to containerize everything. So ultimately it's just a standalone OCI compliant container image. Otherwise, my understanding is it just makes a directory tree full of software that, I mean, it's basically just a Python project just piled into a directory tree.
Yeah, I mean, the nice thing about this sucker is that it certainly doesn't have any requirement on container constructs, right? Because it just runs. It just works like a binary.
Yeah.
Yeah.
That's all. Thanks.
Yeah. Can you package Slack, Debian, Red Hat, Snap builds too? Pop build is pluggable. The only package building plugin I have right now is called FPM. So basically it'll build anything FPM can build. Right, and so there's my Poppy Arch Linux package. So yeah, it can build Debian, Red Hat, FreeBSD, Solaris, Mac packages, a bunch of them. To extend pop build to be able to support Snap or others, the best thing to do would be to create your own project which implements the pop build / PKG subsystem inside of its DINE name, and write it yourself. And then it'll just work. And then I don't even need to see if I like your code. And then it works for people. And then once it becomes popular, and it's proven that people say, yes, I think that's a really good way of doing it, we would consider adding that to the requirements.txt for pop build. So that something gains credibility on its own instead of gaining credibility because somebody else stared at it for a while and said, I'm going to push the merge button, whether it's a good idea or not. Which is one of my fundamental arguments is, I did not mean for popular to be a pun. But that's one of my fundamental arguments also, that code should gain merit not because it was merged, but because it's good and because it's usable and because people use it, right? And it's much easier also to popularize a piece of code if it's got its own repo and its own name, right? I can't tell you how many features are sitting inside of Salt that would be huge if I'd written them as their own feature, or sorry, their own project, instead of a feature that no one's ever heard of called Thorium. And nobody would even compare Salt to Ansible if Salt was just the config engine. And then they say, oh, but it's part of this other thing. Oh, and it's part of this other, you get what I mean? Because that's all Ansible is an SSH tool and a really weak imperative configuration engine. Oh, shoot. Nick, I didn't make it through a presentation without bad-mouthing Ansible.
We'll forgive you.
Sorry about that, everyone. Okay, any other questions? Or should I cede the stage?
All right.
Yeah.
Well, thank you very much, Tom. We really appreciate you having out this evening, and have a good meeting right after this.
And just so everybody knows, I love giving presentations unless you absolutely hated my presentation. Keep it to yourself. If you hated it, if you liked it, feel free to reach out. I'm more than happy to speak at these. These are easy. These virtual ones, holy cow. I can take an hour out of my day to do this. I don't have to fly anywhere.
Yeah, and if you guys want to do another one that's just on pop build, I don't know if we need to or not, but if you find that you've got an interest, I'm sure that Tom will be happy to do that.
Well, and I'd be happy to do one on pop build or the entire config system. The config system is extremely elegant. I'm very proud of it. I think it's, oh, holy cow, it makes the whole config thing so, it's just a problem that doesn't exist anymore. So, all right, thanks.
Thank you.
Thank you.
And then there's no applause. People just drop off a call. It's really weird.
Will the recording be uploaded somewhere?
Yeah, I'll talk to Nicholas about that, and I'm sure it'll be in several places.
Yeah, we don't throw this stuff away.
No way.
Especially when somebody else is paying for the storage.
That's right.
Here you go, YouTube. This is your problem. All right, thanks everyone.
Thank
Thanks,
you.
Tom.